Hi, welcome to this video. My name is Phil and I'm a senior lecturer in astrophysics at the University of Lincoln. And in this video, I'm going back to exoplanets, but also then looking at some unusual orbits of some of the exoplanets that we've discovered. And these are retrograde orbits. So I'm going to explain what they are and how they might actually get in those sort of configurations as we go through the video. So just to kind of start and recap really, most planets, this is not always true, because I've done separate videos on this, but most planets, like the planets in the solar system, orbit their star, basically. So normal planets orbit a star. Again, there are some planets that are floating around in space without stars, they're called rogue planets, but most planets orbit stars. Now, most planets, if they've formed with the star, so when stars are forming, they actually produce this disk around them, this circumstellar disk, this protoplanetary disk, whilst the star is forming at the centre, and then the planets form in that disk up until the point when it then becomes a star. Then all the material kind of gets blown away, so they have a short window to then grow into a planet. But if that happens and they form together, then what you find is that the planet should orbit in the same direction, the same plane as the rotation of the star, and that's due to conservation of angular momentum. The disk is rotating the same way as the star because it's all collapsed from the same cloud. So we expect then the planets to orbit in the same direction that the star is rotating. Again, that's like the solar system. So that's what we would expect basically. However, we have discovered some exoplanets. So these are planets orbiting other stars outside the solar system, and they've been discovered to orbit the wrong way round their star. So the star is rotating in one direction and then the planet is going backwards, and we call that retrograde orbit. If it's going the same way, we would call it prograde. Now that might suggest that they didn't form together. Now at the end of the video, I'm just going to recap, well not recap, but I'm going to introduce a couple of mechanisms that can put a planet on those sorts of orbits, and not all of those relate to a planet not forming with the star. They can form with a star and then end up on a retrograde orbit, but it takes some time and some significant energy to flip it around basically. So the first exoplanet discovered then orbiting the wrong way round or the opposite direction with a retrograde orbit is WASP 17b. This is a fairly large planet. There's the size comparison to Jupiter. Not necessarily a massive planet as in mass wise, but definitely size and radius. It's a very large planet. So a large gas giant orbiting the wrong way around its star. We've then also got this HAT P67P, not PB I should say, and this is another one orbiting the wrong way, another large gas giant as well. And there's not many that have been discovered orbiting the wrong way. It's only a handful really. It's quite rare, and you'll probably see why it's quite rare as we go through the video and understand where they might have come from. But if we take a step back from planets, go a little bit smaller, come back to the solar system, we can have a look at moons around planets. So Neptune's moon Triton is retrograde. It goes the wrong way. Now the yellow orbit here are the normal prograde moons that likely formed with Neptune in the same way that planets formed around a star, just smaller scale, not quite the same mechanisms, but they form potentially in a disk around them. And then you've got this very large moon Triton going the wrong way. It's quite elliptical as well, not circular. And Triton is pretty much the same as Pluto. It's a dwarf, or it would be a dwarf planet if it wasn't orbiting a planet, but it's a satellite or a moon now because it is. It's got an atmosphere. It's the largest moon in the solar system orbiting the wrong way. And it's not the only one with a retrograde moon. All of the outer planets and that do have retrograde moons. So here's Jupiter's. The red orbits here are your retrograde group, and the inner ones are prograde. Then you've got the Galilean moons, and you can see you've got a fairly significant group of retrograde moons there. Now interestingly, I could do a separate video on this. I'm not going to go into too much detail, but you'll notice that the retrograde moons are further out. Now, if you've got a moon orbiting a planet or planets orbiting a star, the further away you get from the main primary body, the less gravitational dominance it has on it, and it's more easily influenced by external gravitational perturbations. And you find that you can't really have them right far out. Yet retrograde orbits can exist a long way from their host body and still remain stable. They're not as susceptible to being disturbed. So you'll find that they can actually exist much further out. Saturn, again, has a fairly significant group of retrograde moons. The red group, you've also got the blue prograde group. But in both of these groups, as in like with Jupiter and Saturn, the retrograde one, you've got a moon going prograde. Now that's going to spell disaster. If that has a head-on collision with another moon, it will likely cause a large debris cloud, potentially a ring system. So it would destroy them, and it would then probably grow into another moon as well. But again, another story for another time. So where do these retrograde moons come from? Well, they're usually captured. They didn't form with the planet. They came from elsewhere. So they came too close and they were gravitationally captured by the planet. And depending on the angle, the orientation that they came in at, they can be retrograde, prograde, very inclined. But it's one of the only real mechanisms for moons to end up on retrograde orbits, because again, they would be going prograde if they formed with the planet, a bit like the planet and the star. However, going up in size, planets can also be captured. So if you've got a star moving around in the galaxy and there's a planet without a star, that's a rogue planet. And again, I've got separate videos on how they might form, what they actually are. If it gets too close, it can be gravitationally captured in the same manner as one of those moons like Triton. And again, depending on the angle of approach, how it interacts with that star, it can place it onto a retrograde orbit as well. So it likely would have come from a rogue or free-floating planet, and these are planets that are not gravitationally bound to their star. Now, there's a few mechanisms or processes which can form one of those. Again, I'll just recap what they might be, but got full videos on those, and they're in space on their own without a star, and that's what we kind of call them. They're not orbiting a star like we would more traditionally think of a planet. And one of the mechanisms in which they can be produced is they can get gravitationally scattered out of the planetary system. They can get thrown out. And when planetary systems are quite young, they're not stable, the planets are still moving and wandering about, they can get close to one another and they can gravitationally scatter each other out of the system. A bit like how we use spacecraft for a gravitational assist. We can take energy from a planet and we can kind of scatter ourselves out into the outer solar system. Well, planets can do the same if they get too close. And if there's enough energy there, an extreme encounter between two planets will throw it out of the system completely. If it's got enough energy, enough velocity, it will be fast enough to escape the gravity of the star, and then it's on its own in space. It's then a rogue planet or a free-floating planet. And then if that planet then interacts or comes close to another star system or planetary system, or even just a star, it can be captured. And again, depending on the orientation of that encounter, it can then place it onto a retrograde orbit. It can be any orientation. It doesn't have to be prograde, retrograde. It can be quite inclined, stuff like that. So that's one of the ways in which we can get a retrograde planet. But it's not the only method. That's one mechanism from a rogue planet, but there are ways that are non-external in the sense that the planet still remains in the system. It formed with the star, but over a very long period of time, potentially, its orbit can slowly migrate or change to a retrograde orbit instead. Now, one of those which is probably a bit faster actually, is if we go back to the extreme encounter where planets can scatter themselves. Sometimes they don't have enough energy to leave the system. So it might actually just scatter the orbit. And in that case there, it might incline it. You could send it out of the orbital plane, even enough to send it retrograde. And this illustration I've done here is not truly correct because I actually put the larger planet being scattered. But in a true encounter, it would be the smaller one, not the bigger one, which would then have the more significant change in its orbit. You've then also got this mechanism here, and I'm not going to pronounce this because my pronunciation is awful, But this is a process where you've got a kind of a distant body, let's say it's a star, and it's kind of tilted, so it's out the plane of the orbit, and it exerts a gravitational perturbation, a disturbance on the planet. It could even be another planet that's on a tilted orbit as well. And over time, it will slowly alter the orbital parameters of the planet. It can make it more inclined, it can make it more elliptical. So that distant object there, that star, will slowly alter the planet's orbit. And actually, it can, in time, flip it from a prograde to a retrograde orbit, and then we have our retrograde exoplanet. Now, I don't think we truly know how these might have formed yet, but there are at least a few theoretical methods which we can consider that can put an exoplanet on one of these particular orbits. So thank you for watching, and if you enjoy the videos or find them helpful, then do consider becoming a member. There's extra videos in the member section, but it also helps support the channel. So thank you for watching.